Welcome to Data Types Part 2, and we're going to start right where we left off in Part 1. You might have seen a little teaser of the different data types that were out there at the end of Part 1, but let's start with the integer data types. Now we're going to talk about integers and floating point values in this video. But what I want to do is go through these data types and let you see the differences in them and kind of make some lights come on about how you can use these. Now if you've been around programming a while, you've seen this, you know this, and you may just want to go on by this video, all right? But if you're new to this or you haven't been in C++ for a while, you may want to take a look. First of all, there is an integer data type called a bool, that's short for Boolean, and that is, notice it takes 8 bits. 8 bits are in a byte, so this is a 1-byte data type, okay? And it stores a 0 or a 1, so we can use this to designate zeros, ones, true, false, yes, no, that sort of thing. Then there is a char or a character data type, and this stores 8 bits, 1 byte. And notice in the char we can store, remember in the videos a little earlier in the course we talked about signed and unsigned data types. If we're using it as a signed data type, the char will store from negative 128 to positive 127. So if we're going to create a variable that's going to store the store locations, and we have these in code numbers, all right, as long as we don't have more than 255 stores, then we can use an unsigned char to store that, all right? So we could easily make that happen. Now notice with a short data type, this is 16 bits or 2 bytes. And notice the signed version of a short, or the signed integer type modifier, gives us from negative 32,768 to positive 32,767. And if we use that as an unsigned data type, then we can go 0 to 65,536. So again, if we're storing the annual salaries of our employees, as long as nobody makes over 65,536, we can get away with using the short data type to store that. Now what's going to happen the minute we try to store 65,537, we're going to get an error and it's going to say overflow, that sort of thing. Now the integer data type, int, or long, either one of these means really the same thing. 32 bits, all right, 4 bytes. Notice you can store from negative 2 billion and some change, I won't read it all to you, to positive 2 billion as a signed data type, and if it's unsigned, you can go all the way from 0 to positive 4 billion and all of that, all right? Doesn't seem right to call 294,000 and something else change, but that's what we'll stick to. Then the long data type is 64 bits. Notice that's 8 bytes, and I won't even try to read this number. It's negative 9 quadrillion up through positive 9 quadrillion and a whole lot of change, okay? So for really large numbers, the long data type. You won't see that very much simply because do you really want to use 64 bits of memory to store, you know, people's age and all that sort of thing, all right? So that's the long data type. Now when we start to talk about floating point data types, the first one is a data type called float. Notice these get rather large. This is 32 bits in size, and the range, now notice this, and you have to kind of watch this. It looks like it's kind of weird, but you have to multiply it out. This is a negative from 1.4023 times 10 to the negative 45th power, that's a large number, to 3.4028 positive times 10 to the 38th, okay? So that's 3.4028 times 10 times 10 times 10 times 10 times 10, large number anyway, okay? The double is 64 bits in size. It goes from 4.9406 times 10 to the negative 324th power to 1.7977 times 10 to the 308th power. Now, how big of a number is that? And that's our two choices, float or double. Keep in mind that we can express our floating point values as a decimal value, for example, 234.5, or we can express it as an exponent as 2.345 times 10 to the second power. So notice that means 2.345 times 10 makes it 23.45 times 10 again makes it 234.5. So you can see when we're talking about 34 times, we're getting to some really large numbers. Now you can adjust in there how many decimal places you want to show and all that, and have all kind of leeway and all kind of adjustment room with these things, okay? But that's your fundamental data types, and you need to kind of get these in your head and make sure that you're using a data type that stores the values that you need but doesn't leave a lot of empty headroom out there where you're just kind of wasting memory, okay? So anyway, that's your fundamental data types.